Okay, so today we're going to talk about radians. We're going to talk about how to convert between radians and degrees, their graphs, and trying to calculate exact measurements using exact triangles. So the learning intention is the knowledge of what a radian is and its relationship to degrees. We'd be successful if we know what a radian measures, if we can correctly convert between radians and degrees, if we can correctly sketch the trigonometric graphs in radians or in degrees, and correctly establish exact triangles in degrees and radians. Okay, so the definition of a radian is a unit for measuring angles based on the length of an arc in a circle, and that's from Maths in Focus 3rd edition. Okay, so imagine we've got a circle here, and let's say it's 1 unit in radius. So the circumference we know is 2 pi r, right? So 2 pi r. And in this case, the radius is 1. All right, so the length of the whole arc, or this going around, for a full one is going to be 2 pi, right? So if I do a full revolution, it's going to be worth 2 pi. Let's say I did a quarter revolution, so I had an arc length of just a quarter of the circle. Well, then that's going to be, or let's do a half of a circle. Well, that's just going to be, so for half a circle, or semicircle, well, that's just going to be 2 pi divided by 2, which is just pi. And if I did it a quarter, so a quarter circle, well, that's still 2 pi over 4, which is pi over 2. Yeah. And that's basically the arc length. So if we just want to find a percentage or a fraction of my full circle, which I know is going to be 2 pi, I just divide it by how much of that fraction I have. And that's what a radian is, okay? So when we want to convert between radians, if we're going from radians to degrees, I'm going to multiply it by 180 times pi. If I'm going to go from degrees to radians, I'm going to go pi. I'm going to times it by pi over 180. Okay. So if this 3 pi over 2, as soon as I see a pi thing, I know it's in radians. Yeah, it's in terms of pi. As I said, a radian is a unit for measuring angles based on the length of an arc. So a radian is a unit for measuring angles in base pi. Yeah, in relation to pi. Okay, so I want to convert this into degrees. So what I'm going to do is I'm going to multiply it by 180 over pi. And I kind of know that pi has to go on the bottom because basically this is going to eliminate each other out. Yeah, so the pi's cancel each other out. 2 goes into 180, 90. 3 times 90 is 270 degrees. Okay, so 3 pi over 2 is worth 270 degrees. Okay, here we've got 60 degrees. I'm going to convert into radians. I'm going to go 60. I'm going to multiply it by pi over 180. Yeah, because, to just remind people, if I was to do half a circle, so if I was to travel this half, I would actually be traveling 180 degrees. And notice that pi and 180 mean the same thing. Yeah, and so that's why I'm multiplying it by, in terms of like half a semicircle, basically. So 60 goes into 183 times. So my final solution is pi over 3. If I want to try 25 degrees, I'm going to multiply that by pi over 180. Well, that's going to be 5 goes into 25 5 times, and 5 goes into 180, 15, carry the 3, 36 times. So we get 5 pi over 36. Okay. The question now says to evaluate sine 1.36 and cos 1.45. We need to make sure that we're in radian mode. And to swap between radian mode is we press shift mode, and I'm going to press 4 for radians. Okay. So if I want to figure out what sine 1.36 is, I'm in radians, it sees that little R there, so I press sine 1.36 and I get 0.97, let's do it to 3 decimal places, yeah, 0.978. And so cos 1.145 is worth 0.413, okay. So, I'm just going to jump back into degree mode, so shift mode, I'm going to press 3 for degrees, okay? And we're basically going to talk about the trigonometric graphs, okay? So, with the sine curve, yep, let's press sine 0, and I get 0. If I press sine 90, I get 1. If I press sine 180, I get 0. If I press sine 270, I get -1. And if I press sine 360, I get 0. Okay, and so let's press sine 45. If I go press sine 45, I get 0.7. So that's somewhere around about here. Okay, and basically what happens is I get this curve that looks like that. Okay. Now, as we talked about, 360 is worth 2 pi. Full revolution is worth 2 pi. So half a revolution is only pi. So if I want a half of 180, which is 90, well, that's going to be pi over 2. And if I want 270, so that's going to be basically 3/4 of 2 pi. So I get 3/4 of 2 is 3 pi over 2. Yeah, because basically this is our full circle that we're making. So 90 degrees is equivalent to pi over 2. 270 is equivalent to 3 pi over 2, which we saw before. And so that's the sine curve. If we're doing the cosine rule, the cosine curve, okay, I'm in degree mode. So if I press cos 0, I get 1. I press cos 45, I get 0.7. Somewhere here. Cos 90, I get 0. Cos 135, I get negative 0.7. Somewhere here. And then cos 180, I get negative 1. Okay. So if I go to radians and I press cos 2 pi, I get 1. So remember 2 pi is over here at 360. So I get 1. 270 we said was 3 pi over 2. So 3 pi over 2, we get 0. And so if I get 315, I figured it out to be 7 pi over 4. So if I do, because that's 7/8 of, yeah, so yeah, I get 0.7. Here we go. And so what we get is this curve that looks like that. And these curves continue on consistently. Okay? And the tangent ones, you could do the same with your tangent, and it basically works out to be these numbers don't exist. The curve comes up like that, and that's basically from our unit circle, yeah. So because the x-axis is cos and the y-axis is sine, yeah. And so when we get to, we want to find tan 90, it's undefined, yeah, and it's same as tan is 270 degrees, okay. So those are the trigonometric graphs in both degrees and in radians. Okay, so is that triangles? We have two types of triangles. We have this exact triangle. It comes from an equilateral Oh no, so sorry. We have two exact triangles. So we've got this isosceles triangle where this is the same as that. So we've got 1 unit and 1 unit. So if I want to find what sine 45 is, that also means that this is 45 degrees as well. Okay, sine 45 is the opposite of our hypotenuse, so it's going to be 1 over square root 2. And we found that square root 2 because 1 squared plus 1 squared is 2, so the hypotenuse is square root of 2. So if I wanted to find cos 45, well, cos 45 is 1 over square root 2. And if I wanted to find what tan 45 is, well, that's opposite over adjacent, so that's going to be 1. Okay. So that's based on an isosceles triangle where each side is worth 1 unit. This one, the other triangle, comes from an equilateral triangle worth 2 units per side. So if that was worth 2 units, half of it would be 1. This would be square root of 3 using Pythagoras' theorem. And we get 60 degrees, because equilateral triangles all have 60-degree angles. Half of 60 is 30. So we get another one where we got, if we do sine 60, well, that's opposite over hypotenuse, so that's square root 3 over 2. We get cos 60, which is adjacent over hypotenuse, which is a half. And we get tan 60, which is opposite over adjacent, which is square root 3. We also then get sine 30. That's going to be opposite over hypotenuse, that's a half. We get cos of 30, which is adjacent over hypotenuse. And we get tan 30, which is opposite over adjacent. Okay, note that these two swap around. Yeah, they're complementary angles. So that means that if 45 degrees, if we turn 45 degrees into a radian, it's going to end up being pi over 4. So sine pi over 4 is still 1 over square root 2. Cos pi over 4 is 1 over square root 2 as well. And tan pi over 4 will give us 1. And we can test that if we're in radians. So tan pi over 4, we get 1. Perfect. 60 is pi over 3, so sine pi over 3 is square root 3 over 2. Cos pi over 3 is a half, and tan pi over 3 is square root 3. And 30 is pi over 6, so sine pi over 6 is square root 3 over 2. Cos pi over 6 is that's a half. This is square root 3 over 2. And tan pi over 6 is 1 over square root 3. And we can use lots of calculating things to exact values using these measurements. Okay, so thank you.